Hello, in this video I will discuss how to run 1D sock tube simulation in OpenFoam, and we'll also validate the results with the analytical solution of the 1D sock tube. So before running 1D sock tube simulation, we must know what is a sock tube. You can follow the Wikipedia page, and from here the original paper of 1D sock tube is available. And if you will enter into the paper, here you can see the sock tube is clearly described. You can assume that there are two regions. In one region the fluid is at high pressure and high density, and in the other region the fluid is at low pressure and low density, and in both the regions uh, the velocity is zero. But when you will separate the diaphragm, the there will be flow of fluid, and there will be change in pressure, density and velocity in both the regions. So this sock tube test is particularly popular in compressible fluid dynamics community, and we are mainly using sock tube test for validation of new solvers. So let's enter into the sock tube folder, and if you will go to tutorials, compressible, in row central form there is sock tube. So you can see in the zero folder there is pressure, temperature and velocity, and there is constant folder and systems folder. Here we will mainly solve the 1D sock problem, and you can see in x direction the minimum value of x is -5 and maximum value of x is 5, and we have 200 divisions in x direction, and we are solving mainly 1D sock problem. So I'll start a new terminal and I'll enter into the folder sock tube 3. So first I'll run block mesh, and the next step is set fields. Here you can see the set field file is there, and we are dividing the domain into two divisions. One division is from x equals to -5 to 0, and another division is x equals to 0 to 5. So in the left domain the temperature is 348.432 and pressure is 100 K, and in the right domain the temperature is 278.746 and pressure is 10,000. So if you will check the 0 folder, you will see the initial condition is not defined. So to define the initial condition, here you have to run set fields. Now you can see the initial condition is defined. In the left domain there is high pressure, and in the right domain the low pressure is there. And similarly, if you will check the temperature file, there is high temperature in the left domain and low temperature in the right domain. So the next step is to run simulation, and this is row central foam. And before running simulation, I'll check one more thing, that is the time step size and the initial and final time. And here you can see the start time is 0, end time is 0.01, and delta t is 1e minus 6. So I'll start simulation. Here you can see the simulation is finished, since this is a 1D case. And next step, we'll post process those results using ParaView. Here I'll run ParaFoam. Just click apply, and here you can see different time steps. So the shock is propagated through the entire domain. And next I will export data along a line in x direction. So first I'll generate a plane. Next I'll generate one line. And from here you can see the shock profile. The next step, I'll export the data over this line, and I'll save all the time steps data. And here you have to click write all the time steps. And here you can see all the data for all 10 timestamps are generated in the folder. And I have written one Python file, ipynb file, to post process the results. So from the terminal, I'll start Jupyter Notebook. And to learn more about how to install Jupyter Notebook, you can refer the Python playlist in my YouTube website. And from here, you can see I've written a simple Python script to post process the results. And in these figures, the blue line is for analytical result, and the yellow line is our simulation using OpenFoam. There is some problem with the file name. It's form. So this is the profile of velocity, and this is the profile of pressure, and this is the profile of density. So you can generate this analytical data file using the SOCTube problem solver that is available in MathWorks website. And here you can see the analytical solution of 1D SOC problem. This is available in MathWorks website, and I'll share this link in the YouTube video. So in this video, I discussed how to run OpenFoam simulation for 1D SOCTube problem, and we defined the initial conditions using setFields method, and we successfully run simulations, and we validated our OpenFoam results with the analytical solution of the 1D SOCTube problem. And I'll share all these case file and the Python script in my repository I have created in GitHub, and I'll upload all the files in this repository. Thank you.